In this question, the results of a series of consolidated undrained triaxial tests is given to you. So we know that in undrained tests, U is not equal to 0, and the values of U is given to you in this row. The values of sigma 3 and sigma 1 minus sigma 3 is also given to you in the first two rows. And the shear strength parameters of the soil is asked to be determined by you. So as you already know, sigma is equal to sigma prime plus U. So we have the value of sigma, we have the value of U. We can determine the value of sigma prime, and we know that the relation between sigma prime 1 and sigma prime 3 is this equation. So if we have the value of sigma prime 1 and sigma prime 3, the only unknown parameters of this equation would be our phi prime and c prime. So for each equation we have two unknown parameters, and we need at least the result of two tests in order to determine these two values. So first of all, based on the results of this table, we have to determine the values of our sigma prime 1 and sigma prime 3, and then I'm going to explain what to do next. So these three columns are exactly the same as these values of this table that is given to you. Sigma 1 is some of these two columns. Sigma prime 3 is sigma 3 minus U, and sigma prime 1 is sigma 1 minus U, or column 4 minus column 3. So now we have the value of sigma prime 1 and sigma prime 3 for 4 tests. And if we write this equation for each test and then use two of these equations for 2 tests, we can determine different c prime and phi prime for each 2 tests. For example, for the results of these 2 tests, we can write 171 is equal to 68 plus phi prime divided by 2 plus 2c prime tangent of 45 plus phi prime divided by 2. And then for the second test, 333 is equal to 131 45 plus phi prime divided by 2 plus 2c prime tangent of 45 plus phi prime 2. And then if we subtract this equation from this one, we will have 162 is equal to 63 and from this we will get phi prime is approximately equal to 26.1 degrees. And now if we put the value of phi prime in any of these 2 equations, we can determine the value of c prime. So if we use the first equation, we will have 171 equal to 68. And then from this equation, you will get a C prime equal to minus 1.2, which we know it's not an acceptable value because C prime has to be equal or greater than 0. So if we repeat this procedure between each two tests, so we have 4 tests, we can do between these two tests, between these two tests, between these two tests, or between these two, or these two, or these two tests. 1, 2, 3, 4, 5, 6. We can repeat this procedure for 6 times, get 6 different values for 5 prime and 6 different values for C prime, and take an average. That's one way to do it. And the other way, which is easier, is using Morse circles. So for each test, we can draw its Morse circle, and I'm going to show how to determine the value of C prime and phi prime using the Morse circles. So for the first test, the value of sigma prime 3 was 68, and the value of sigma prime 1 was 171. So 68 would be somewhere around here, and 171 would be somewhere around here. So the Morse circle would be something like this. For the second one, they have 131 and 333. So 131 would be around here, and 333 would be around here. So the second Morse circle would be like this. For the third test, 198, 503. So somewhere here and here. The Morse circle would be like this. And finally, for the last one, we have 269 and 679. 269 somewhere here, 679, and the Morse circle would be something like this. And now if we draw a common tangent line for these 4 circles, we'll get something like this, and this will be the value of our phi prime, and as you can see, our C prime is almost equal to 0. Phi prime is around 25.5 degrees.